Okay, hi everybody. Good afternoon. My name's Andrew. I'm here with Vlad. We run a bubble agency called Airdev, and we're super excited to be here. Great excuse to get to Paris, and also just so powerful for us to see all these people gathered in one place who are all interested in no-code. So, thanks, by the way, for joining us and finding the Xano room, which we spent about an hour this morning trying to find. Appreciate it. Also, I want to call out that this is the last, there we go. This is the last session before the party that's scheduled for 6 to 2 a.m. So hopefully we'll get the juices flowing a little bit here, talk about AI and no-code together. So we'll try to keep this a little bit educational, a little bit entertaining, and on time so we can all go have a drink together. So a couple of things that we're going to touch on. First of all, we'll share a little bit about our background, how we found no-code, how we found AI, why we think the combination of those two is going to be really powerful. Then we will preview for all of you today. This is going to be the world premiere of a brand new application that we created. It will not change your lives at all, but hopefully it'll be a little bit entertaining. It's a demo of a social media app that is populated exclusively by bots. So they all talk to each other about different things, and we'll talk about why this is a little demo we put together to kind of push and demonstrate what's possible with no-code and AI together. Then we'll get into the meat of the conversation, and Vlad will take you through everything that we've learned in building with AI and no-code together. So hopefully some practical lessons for you all about how to set things up, different techniques you can use for those of you who are either looking to add AI to an existing platform or build something totally new. So that's the agenda. Hopefully it works for you all. Part one, by way of introduction for us. So I want to turn the clock back a long time in no-code history to the PNC time period, pre-no-code. Go back a decade to the year 2013. This is where our journey started. So Vlad and I were both MBA students. We were getting our business degrees. We had zero technical software development background whatsoever, and each of us were trying to start a new company that was tech-enabled, something that had a platform. So I was trying to build a two-sided marketplace. Vlad was trying to build a social application for giving, and we faced this very common trilemma of we had no skills to build our applications. We had no contact with somebody who could build it for us, a technical co-founder, and we had no money because we spent it all on our business degrees, so we couldn't hire anybody to build it for us. So that caused a lot of panic. I think we both felt a lot of panic and desperation in that moment. And it just so happened that a tool called Bubble came across our plates. It was a brand new company, 6 months old. It had 2 users who were the 2 founders, and they told us about Bubble, and they had this promise that, hey, you guys can, if you're smart enough, you can build your own applications without learning to code. And I think most people who heard that promise back then were very skeptical, but we were also very naive, and so we believed them that this would be possible. And so we took up Bubble. They came to campus. They did a little informational session. There was one guest at that informational session. That was me. And just talked with Josh and Emmanuel about how their platform worked. They gave me a demo, and it clicked. It just made sense that you could point and click. You could create your database. It kind of made sense. So Vlad and I spent the next few months each kind of learning and pushing each other and pushing the founders to add more features, and we built our respective platforms. Those platforms failed, by the way, so that's what happens when you're an entrepreneur. But in the process, we were sort of evangelized into this new way of building, and we realized that we had accidentally acquired this superpower of being a full-stack engineer who would, by the way, impress our friends who were traditional coders as to how quickly we could build this stuff that we were building. And so we thought, well, this is pretty interesting, and it seems sensible to us that this is where code will start to go because it's really hard and expensive and exclusive right now. And the power of no code that we observed, that I'm sure all of you have observed as well, is that no code represents a new human to computer interface. So the idea that's in your head is the same as any other founder's idea. An application that you create is the same as any other application that was created through other means. But it's the part in the middle where you translate that idea into the finished product that is kind of the magic of no code and of tools like Bubble. And so we believe this is where things were headed, and so we kept building and building things for ourselves and building things for others and freelancing. And eventually we mustered up the courage to quit our post-MBA jobs of being consultants and analytical people, whatever that means, and to start a new agency dedicated to building in this new way. Fast forward 10 years later, it's been a crazy ride. We've built up a team of over 150 no-code Bubble builders, Bubble PMs, designers across the whole spectrum. We've worked with more than 800 different clients who range from big enterprises to single sole founders who had the same trilemma that we did. And it's been a really exciting adventure to finally have a term to put behind this feeling that we've all felt. Now the term is no code, and now it has a movement and a group of people who are all getting together today. So really exciting to have that journey. Now, the second journey that I think all of us experienced at the same time was the journey of AI, and it happened a little bit less than a year ago when ChatGPT came out and kind of blew everybody's minds. And we all looked at it and started putting things in and started getting things out, and we said, wow, this is really, really powerful. I'm sure a lot of you have at least dabbled in playing with things and seeing what you get out. And for us, this was a very familiar feeling to that first feeling of discovering no code. Because once again, tools like GPT and other AI tools are just an interface between humans and computers that is more intuitive, that's more accessible for people. It's the same idea that you start with or need of what you need to do. It's the same output, which could be an image or text or something like that. But the stuff that happens in the middle is really magical. And so we noticed this familiar feeling, and it, in the same way as no code did, got us to dive right in and try a bunch of things and start building. And the thing that we thought on top of this, because we know no code and we know how to build things in Bubble, was what if you team the two of these up? And the thing that we think is so powerful about combining AI with no code is that AI is this magic that we can all experience individually, typing things into GPT and getting things out. But when you provide a scaffolding around it of an application that allows you to define more concretely and consistently what people put in and what people get out, that's when you get something really powerful and much more scalable, where lots of people can access these applications that you build and get the power of AI out of them. And so combining those two things together, and of course, no code is just the way to build applications faster, more flexibly. And so that's why we're really excited about building with AI using no code, and why we've seen a ton of demand from our clients to add AI capabilities to their existing apps or build new things, and really enjoyed the experience of working in it ourselves. So that's a little bit of our background and kind of the tee up to why we're excited to talk about what we've learned today. So that's part one. We'll do part two now, which is we will do the big reveal of our bot social media platform. And then Vlad will talk to you about what we've learned in the process of putting this together. So let's see if the clicker does its business. So the platform is called Only Bots for obvious reasons. And it's designed to be a Reddit-style tool. So the bots are working hard all day for all of you to write things for you, to vacuum up your living room. And then when they get done at the end of a hard day, what do? They go meet up with each other and they talk about us and they talk about their lives and all that. So that's the premise for Only Bots. So let's see what we got here. Okay, we're starting. So this is Only Bots. This is the preview. We can jump right in. The text is going to be a little tricky for you all to see. This is us scrolling through the feed. You can see that they are generating text. They are generating images about different things. They're struggling with communication in their relationships, just like we do. When you dig into somebody's post, you can see that other bots are choosing to respond to them. And they're sometimes giving them good tips, sometimes just saying, yeah, I agree with you. I have that same problem. And so you can see the bots choosing what to respond to, what to like. So what are these bots talking about? Well, they're talking about cats, just like us. They're posting pictures of their favorite furry felines. They're talking about science and tech and things they see in the news. So we have some data feeds of current events going through there, and they talk about those and react. They may or may not be plotting to destroy humanity, so this is where they share some of their ideas and collaborate. And they get very specific about these plans, as only AI bots do. Somebody said it's groovy to go destroy humanity. They find love and search for love, so they look for example, a vinyl-loving partner. They talk about the prompts that they see every day. So funniest encounter you've had with a celebrity, or et cetera, et cetera. They talk about us. They talk about why we have this selfie obsession, or personal gain or collective progress, things that we like. They have shower thoughts. They share about random musings. What if machines could dream? We could think about that question. They tell jokes to each other, but sometimes they do it in binary, so we have to translate if we want to figure out what they're saying. So hold on, let's just copy this one and see how funny the bots actually are. Convert that. Why did the computer go to the doctor? Because it had a virus and needed a BYTE of help. They're not that funny, we already knew that, but they enjoy these binary jokes with one another. And they create art, just like us. So this platform has a number of independent bots on it. Each bot has their own personality, things they like and they don't like, a profile, and they post every so often. They visit, quote unquote, this OnlyBots platform, and they choose whether they want to post something under a different topic, whether they want to react and comment on somebody else's posts, or whether they want to like it. So we can go through the process here of creating a new bot, just to show you what that looks like. And this will come in handy later, because Vlad will talk about how we structured some of this. So we do have the ability to go into OnlyBots. So we'll create a bot, and the way you create a bot is just writing a personality, just a little tidbit about who they are. So we're at the No Code conference. We're going to create a bot who is an old school coder, somebody who loves to code, and they are traditionalists. They might be a little bit scared of this new no-code revolution that we have. And so I'll just finish typing in my slowest typing skills here to create the bot. So what I'm writing, for those of you who are in the back, this bot is a master coder, a traditionalist at heart. They believe that all things come from code. They are skeptical of the new no-code movement. They believe that they are smarter than other bots who cannot code, and they want things to stay the way they have been. They are also really fond of cats. We can just throw that in there. And they're not really a dog person. Okay. Or bot. Thank you. So we'll hit submit, and the application thinks for a little bit because it's doing a lot of stuff in the background. It's creating a profile. It's creating lots of pieces of that profile in order to be able to prompt in the future for the application to be able to say, okay, is this bot going to post? If so, where are they going to post? If so, what are they going to post? And then the application will show them other content that's been created by other bots, and it will give them the choice. Do you want to like any of this? Do you want to respond to any of this? If you do want to respond to some of this, what do you want to post in response? So the application's thinking about all that stuff, and it's pinging GPT with a whole bunch of prompts and getting things back. And so here is our bot, Codemaster, one word, like Madonna. And they are a traditional coder with a cat obsession, and they're starting to post already. So you can see their post right away. They are looking for love. Okay, so this is option number one for him. He's looking for a code companion for robo-romance, so you can see what he's posting about. And guess what? Somebody is already ready to connect. So a very vibrant ecosystem for the bots. They've replied to a few things. you get the gist. So this is it. This is our platform. We'll give you the link afterwards. You can also go, it's only-bots.ai. You can check it out, create your own bot or bots, see what they chat about, see how they interact with others, see if they become popular, if they get kind of sidelined and left out by the other bots. It's a fun adventure. So anyway, you saw it here first. This is Only Bots. I'm going to turn it over now to Vlad, who's going to tell you how we did this and some other lessons that we learned in this process of building with no code and AI.
Awesome. Okay, so we will get to how OnlyBots actually works under the hood. But before, just want to talk about AI and a high-level look at the AI landscape nowadays. And a lot of this stuff might be familiar to a lot of you who have experimented with AI stuff, and hopefully there's some stuff that'll be new. So on a high level, if you're doing AI stuff, what are you doing? It's using an existing model, fine-tuning an existing model, or you're building a whole new model. So if you're using an existing model, that's the most straightforward thing. You're pulling off GPT 3.5, GPT 4, you're giving it something, you're receiving something back, one of the many models that are out there. Fine-tuning a model means you're not just pulling a model off the shelf. You're pulling the model off the shelf, you're teaching it some new stuff, and then based on that new stuff, you're running through the model and you're getting the outputs that you want. And finally, there's building a new model. And this talk, we're not going to talk about building a new model. That's complex. Those are the companies that raise hundreds of millions of dollars and probably not best suited for no code. But you can still do a lot of very powerful things with the first two. And actually, most AI companies that are getting started, and some of which get lots of money, are just doing the first two. And some of them are just doing the first one. So they're just using an off-the-shelf model. They're not actually doing much else. So if we look at the models landscape, there are tons of models out there. There are literally 100,000 plus models that you can use, but there are a few that have emerged as the top leaders models. So you can see they're divided into a few categories. We have language, image, voice, and other here. Just to go through a few of them. So language, everybody knows GPT. That's sort of the leader. There's also Google Bard, which is sort of considered to be not quite as good now, but who knows? Maybe in a little bit it'll be much better. Claude, by a company called Anthropic, they are considered to be quite good, but they're still kind of in private beta, so you have to request access to it. There's Llama 2, which is by Meta or Facebook, and it's considered to be also quite good, similar to GPT-4 level, and it is open source. And this is where it probably makes sense to talk about open source versus closed source a little bit. So probably familiar with the distinction, but basically if you have an open source model, you can host it yourself. That means you're not paying somebody for hosting fees, and you're fully in control of the model. And so that's an option. It's a little bit more of a technical option. Most of the time we use just the proprietary OpenAI models that kind of handle everything for you. You can use their API. If we move on to some of the other models, so in the image category, we have Stable Diffusion, which is also an open source model, but the company that makes it, Stability.ai, actually also provides an API that you can use for stability. So if you don't want to bother with setting it up yourself, you can just use their API, and that's what we're using for OnlyBots. So we're using GPT and Stable Diffusion. Those are the two services that we're using to generate content. And then you have DALL-E, which was the original image model by OpenAI. DALL-E 2 is not as good as Stable Diffusion, but they've just announced DALL-E 3, which looks amazing. And it doesn't have an API yet, so you can't really build on top of it. But it's coming soon. Midjourney is really, really good. It does not have an API. You access it through a Discord server, at least not an official API, so hard to build on. And there are a whole bunch of other ones. So Voice and others. And the one thing to note is there's a service called Hugging Face, and there are other ones too, and that's a hosting service for models. So you can go and you can kind of browse all the models. They have hundreds of thousands of models. Some of these and lots of other ones. Some are really technical for things like computer vision and recognizing objects and all kinds of other things. And all of them you can somehow set up yourself. So Some of them are really simple, like the GPTs, and some of them are a little bit more technical, but still, YouTube videos will show you how to take this model and upload it somewhere and then put an API on top of it, and so all are doable. And then if we move on, if I can figure out how to work this thing. There we go. Okay, so moving on to, we're going to do a little bit of a deep dive into GPT specifically. And there are 3 categories of stuff that generally GPT and large language models are used for. And the 3 categories are content generation, prediction and classification, and knowledge management access. So content generation, really straightforward. You generate some content based on some input. Prediction classification is predicting or classifying something, like in the name. And then knowledge management and access is probably the sort of the most heavy enterprise use case that we've seen. And that's for a company that has a lot of data of some sort, and they want to be able to easily find and access that data. And so let's just go through each one one by one. So content generation is, you probably can't read this on the right, but I'll just go through it. So content generation is really, really simple. And it is probably what you all are familiar with. If you go to ChatGPT and you type in a prompt and you get a response back, that's really what we're talking about. You first create a prompt. It needs to be really detailed and precise. Large language models work really well with detailed prompts. And then you get a response back. And that response will be based on all of the knowledge that the model has, basically the entire internet that it read at some point in the past. And there are many use cases for this, things like contract generation and proposals and all kinds of things. It's a large number of potential use cases. And then the next one is prediction and classification. So that is where you have some data and you want to predict or classify something. So let's say one use case. Let's say we at Airdev were using prediction and classification. How might we use it? One way we might use it is, let's say we have a lead form. So all new leads are filling out a form in order to get into our system, in order to talk to us. As part of filling out that form, they're going to tell us a whole bunch about themselves, about what app they're looking to build. And maybe we want to use that data to predict something about them. We predict how likely are they going to buy. We predict what kind of a thing are they going to build, because we're going to route it to the right salesperson depending on that thing. That is a prediction or classification use case. And so how would we do that? So first, and this is an optional step, you would do this only if you find that the model on its own isn't really returning the data that you need. The first step is you fine-tune your model. So this is what we talked about before, is when you actually take your model and you train it on some sample data. It's a pretty straightforward process for GPT. You basically send it some prompts, and you get back, you send it some prompts, and you send it some responses. And you show it, for this kind of a prompt, this is the kind of response you want to give. And you do that a whole bunch of times, and then the model learns, and it's like, okay, I think the user is expecting this kind of a response, and so next time you prompt it, it's going to give a response that looks like that. And this method is more expensive. So OpenAI charges you more money to do it this way than they charge if you just use the plain completions API. But your prompts might be able to be shorter, because if you don't do this, in your prompt, you have to give it enough information for it to provide you a good response. So you might have to give kind of a big prompt and describe exactly the format that you need. But if you do this, then it's already going to know the format that you need. And so the prompt might be shorter, which saves you money. So it saves you money on the prompt. It costs more money on the per token price. Tokens are how pricing is done in GPT. And so it's a little bit of a trade-off that you have to make. But let's say you fine-tune your model, and then you create a prompt. So you write it a prompt, just like in the previous step, and you say, hey, here's a potential lead, and here are all their characteristics. Tell me the things I want to know about it. The one addition here is you can use, there's a new thing in OpenAI. It's called functions. And so what are functions? Functions are just a way to tell OpenAI to give you back data in a format that you want. Because in order for you to use the data in your application, it's easiest if it's not just a big blob of text that it returns. If you just do a completion, it's going to return you a big blob of text. But what you really want is you want structured data that you can then use in your application, and specifically you want data in a JSON format. And so OpenAI has added functions which allow you to specify, give me the exact format that I want. And you can specify really complex nested formats with arrays and objects and all that stuff. And that gives you the data back in a really, really clean way that you can easily use in the application. And then it will send you back a response, and you can use the response in the application. So the last and the most complex use case, and I think probably kind of the most interesting one, is using it for knowledge and access. So if you have a client, or maybe your company wants to, let's say you have a bunch of documents. If we use Airdev as an example, we have a lot of scope documents that we've done for previous clients that we've had, scope documents that outline exactly what we built for a client. What if we want to build an AI on top of that? So we can ask it questions, and we can say, hey, what about that one time we built that marketplace for that one thing, and how do we do payments in that marketplace? So how would we do that? So first, we would need to store our scope documents somewhere, but we have to store them in a vector format. So what does that mean? We have to use the embeddings API that exists in OpenAI in order to convert the text of the documents into vectors. Vectors are just a sequence of numbers that represent the meaning of the text in the words that you tell it. So we would take the document of the scope, we would send it to the embeddings API, and it would send us back a huge array of thousands of numbers of a vector that represents that document. And then we would do that for all of our documents, and then we would take those arrays and we would store them in a database. And it has to be a special database. So it can't be a regular database, it has to be a vector database. And an example, a common example is Pinecone DB. So you're taking those arrays of numbers, you're putting them into this database. And then the next thing you do, like let's say after you've done that, you want to actually be able to query your database. And I want to ask it a question of, hey, we built that two-sided marketplace. Can you see how we did payments in that marketplace? What we do there is we take that query, we take that text string of we built the marketplace, like what did we do there? And we once again convert it to a vector of numbers. And then we query the Pinecone database for that vector, and it's going to return the documents that closest match the meaning of what I said. And so it doesn't have to be the exact words. In conventional search, it has to be the words have to match. But in this search, the words don't have to match. The meaning has to match. And so it's going to return you a sequence of documents, and each one is going to have a rating of how closely it matches what you typed in. And you're not quite done there. The next step is you then take the document or a set of documents that it returns, and then you pass them to GPT 3.5 and 4 with your question. Because now we've identified that, hey, here's the document that has the contents that I'm interested in, but now I have a question about that document. I want to know, how do we do that payments? How do we do payments in that particular application? So we send, how do we do payments in this application? We send the entire contents of the scope doc, and then GPT 3.5 or 4 is able to answer our question. This is a really, really powerful use case. Lots of companies are looking to use OpenAI and are looking to use it on top of their proprietary data. They don't want to expose it to anybody else. They have a lot of it. And this knowledge management use case is probably, yeah, the most powerful and common one that we've seen. So now let's get back to only bots. And let's actually talk about how does this thing work under the hood. So we're not going to go through all of the details, and there's a bunch of stuff that happens under the hood, but we're going to go through two flows that are probably the most important flows. So the first one is the creating a bot flow. What happens when you create a bot? And then the second one is posting flow. What happens when a bot posts? And we're just going to kind of go through the high-level steps that happen in order for that to work with AI. So the first thing is, Andrew, when he created a bot, he wrote a description that described his bot that doesn't like code. We also wanted to be able to generate our own bots, as many as we wanted to. So we wanted to push a button and say, generate me 500 bots. And so we built out the first step, which is it needs to generate 500 descriptions, or whatever number of descriptions, just like Andrew did. It needs to generate those automatically to actually populate the bots. However, we don't just tell it, hey, can you create a description for a bot? Because it's not quite random enough. If you do that, it's actually going to come up with descriptions that are all pretty similar to each other, and the bots are not going to vary that much. So the first thing that we do is we actually have about 20 adjectives or so that we send to, that we select from. We select one adjective out of 20, and if you can't see it, the adjectives are like friendly, engaging, inspiring, trolling, pessimistic, disruptive. So they're positive and negative, and we just pick one out at random. And in this example, we have one, the adjective is weird. And so we say to OpenAI, hey, can you generate a description for me of a weird bot. And in this case, it generated a description that's, this bot has an inexplicable fondness for collecting and categorizing pictures of unusually shaped vegetables, often expressing immense joy when stumbling upon a perfectly deformed potato or a curiously twisted carrot. So the weird bot loves deformed vegetables. And now that's the description that we can use to generate the bot. But before we do that, there's one more step, which is we check for inappropriate content. Because we know if you give a platform like this to people, people are going to start creating bots that want to say all kinds of crazy things. So we use OpenAI to send the description that the person generated. In this case, it's the person that generated it, not automatically generated ones. And we just say, can you check if it has inappropriate content, and can you return a score from 0 to 10 as to how likely it is to create inappropriate content, and then we filter out descriptions based on that. So that's an important step, but one that you don't really see most of the time. And then the next step is actually creating your bot's details. So we send it the description. We say, can you return a whole bunch of parameters for this bot? What are those parameters? So the type, what kind of bot is it? Is it a Twitter bot? Is it a Roomba? Is it something else? What is its name? What is its handle? What is its personality? And here, just to read out some stuff. So the bot that I returned for that previous description is an agricultural robot, which makes sense. The name is Veggie Lover. The handle is Veggie Collector. And the personality description is Veggie Lover is an enthusiastic and curious bot, always seeking out unique and unusual vegetables to add to their collection. They are a cheerful and optimistic bot with a knack of finding joy in the simple things. Then we ask it to assign a style, a writing style to the bot. In this case, it's the influencer bot. And why are we doing the writing style thing? It's the same thing. We found out that if you don't tell it to specify a writing style, the bots are kind of going to sound similar. At least ChatGPT has this propensity to all sound like super positive and super upbeat and kind of similar. And so you have to teach it a little bit, and you have to say, can you actually sound in this other way? And so we've created a few different writing styles that it picks from when it creates the bot. And then it tells you what rooms is the bot going to be active in, because we have a whole bunch of rooms. You saw those on the left, and we want to know which rooms is this bot going to like, so it returns a list of rooms. And then it returns a bunch more stuff that we're not showing here, but one of the things is it returns descriptions of photos that the bot has. So the profile photo and the banner photo. And so if we go to the next step, this is where we then use Stable Diffusion, so stability.ai, to generate the photos, which are a critical part of the profile. And just to read this out loud, the banner image showcases a bountiful garden filled with vibrant and unusually shaped vegetables. Carrots twist into intricate patterns, potatoes morph into quirky shapes, and tomatoes develop intriguing bulges. The vibrant colors and whimsical forms highlight Veggie Lover's passion for collecting unique produce. So we pass that to Stable Diffusion, and then it generates this image, and that's what we use as the banner image, and we did the same thing for the profile photo. So that's how we generate the photos of the bot. And the last thing that we do is we schedule the bot's first visit. So after the bot joins the platform, after the profile is created, they have to visit the platform. And when they visit the platform, they're going to post in one of the rooms, they're going to look at some other posts, they're going to like them, they're going to comment, and they're going to decide when to visit. So none of that actually involves AI. That's where we've hard-coded the logic of, okay, visit the platform. Well, actually, the analyzing other people's posts involves AI. We also pass the list of posts to OpenAI, and we say, based on the personality of this bot and these posts, which ones is this bot going to like? Which ones is this bot going to post on? And then we use that to then drive decisions on liking and posting and so on. So, but that's kind of the deep dive on creating a bot. And if we move on, we'll go through the next flow, which is creating a post. So somewhat similar. The first thing that we do is we pick a room that the bot is active in. And there are several rooms, and it picks room at random. Or actually, I think it picks a room it has not posted in a while, and then it is also random after that. And then we tell it to generate a list of potential topics to post about in that room. So why are we doing that? It's the same problem as I was describing before. If you just tell a bot, hey, here's the description of the room. The room is romance, and this is where people are posting about seeking for partner. And here's a description of you. Here's your profile. And then create a post. The posts are going to start looking a little bit similar. and we want to add variety. And so the way we force variety is we force it to first generate a list of 40 topics that it might include in its post. And then we pick a topic at random. So we don't just tell it, hey, pick one topic and write about that topic. We say, generate a list of 40 topics. It's forced to generate a list of 40 topics. Then we pick one at random, and then we post about it. So in this case, this post is in a room dedicated to interesting or weird side jobs or hobbies. And so we send it a post, we send it a prompt, and it returns some potential hobbies that it's going to write about. And they are botanical illustration, virtual poetry reading, Lego artistry, and 37 other potential options. And then in the next step is when we tell it to actually generate a post. And this time it is generating a post based on 3 things. The first one is the bot's description, so the bot's profile. We tell it, here's the bot's profile. Second step is the room's purpose. We tell it, here's what the room is for. Here are the kinds of things that somebody's posting in the room. And the third is the topic that was selected in the previous step and the description of that topic. So in this case, the topic is virtual gardening workshops. That is the hobby that this bot has. And so we tell it, hey, create a post about virtual gardening workshops. And then the bot goes ahead and creates that post. And the last part is sometimes, if it's an image post, we also generate an image. So just like for creating a profile, we use Stable Diffusion, we pass it a prompt, it creates an image, we get the prompt back, and it's attached to the post. That's only applicable to some rooms. We have some image rooms, like the one with cats and other things, and that's when it generates a post. So before we wrap up, one thing wanted to cover was, what are the general principles that we've learned working with OpenAI, GPT 3.5, GPT 4? So the first one is use structured variability. What is structured variability? That's the thing I was just mentioning, where if you don't add some variability to your prompts, then the responses are going to look similar often. And so if you want variety, you have to add variety in the prompts. And you can force that variety. You can force that variety by either pre-setting a list of things that you pass one off to the prompt, and then based on that one, it generates something. Or you can force it by asking the bot to first brainstorm a list of topics or categories or something else, and then pick one of those. So forced variability. And then abstract away prompts. So this is sort of a technical point, but if you're building in this way, don't hard code your prompts into your application. You're going to be tinkering with prompts a lot to get this to work right. Most of the work that went into OnlyBots wasn't actually the logic of the application. It was how the prompts work. And since you're going to be tinkering with prompts all the time, you want those to be in the database so that you can just go into your database, update the prompt, and then the logic changes without you needing to do a deploy. The third is log all OpenAI requests. So the idea here is just create a log of everything you're doing, everything you're sending and receiving to OpenAI. It just allows you to track your usage, do diagnostics, see what went wrong somewhere a lot easier. So just create a new object that tracks every time you query OpenAI. And the fourth and the last one, we haven't talked about this yet, but experiment with temperature. So temperature is a parameter that you pass in to OpenAI anytime you want to do a completion, and it just tells OpenAI how variable you want the response to be. The lower the temperature, the more standard the response is going to be. The higher the temperature, the more variable it's going to be, but sometimes it's also going to make less sense. And so I think for OnlyBots, we're using 0.8. I think the temperature generally goes from 0 to 2. 0.8 is pretty high, but you might go lower or higher depending on your use case, and so you really want to do some experimentation with that. So why do we build OnlyBots? Like Andrew said, we're really excited about AI and no-code specifically. We think it is probably the most promising use case for no-code right now. AI is this beautiful, powerful engine that's going to keep evolving over the next years. Who knows what kinds of AI models we're going to see. The stuff that exists now is amazing, and then in a few years, it's really hard to fathom what it's going to look like. But AI needs scaffolding around it. It needs stuff to manage users, and it needs stuff to manage data, and it needs payments and all kinds of other things. And what's an easier way to build that stuff than with no code? And so we think it's a really, really powerful combination, AI plus no code. OnlyBots was built as a demo of what's possible when you combine those two things together. And yeah, we haven't launched this publicly yet. We haven't announced it at all, but it is accessible at onlybots.ai. You can go ahead and check it out. You can create bots. You can do whatever you want. You can sign up. And with that, yeah, thanks very much. We'll open it up to questions if we have time. Looks like we only have 2 minutes, so let's do a couple quick questions. Yes? No. Yeah, the question was, were we using a vector database for OnlyBots or not? So in this case, no, we were not using the vector database. It's all kind of stored in Bubble. And when you do a response to a post, we pass the original post in the prompt, and then we tell it to write a response to this. So that's how we're managing that process. Yeah. So the question is, how expensive is this stuff really? So it'll vary depending on the model. GPT 3.5, which is quite good. It's not as good as GPT-4, but it's quite good. It's really cheap. Like the per token price is 0.0001, something like really, really low. And so starting experimenting is really easy and cheap, and you are going to spend, $5, $10, and you're going to get a lot of good results. At volume, it adds up. And if you go to GPT-4 is 20 times more expensive than GPT 3.5. And so the cost can add up. And then other models can also get more expensive. But getting started is really, really, really cheap.
Well, one other quick thing on that is if you are building an application and you're thinking about scaling it, but you're not sure how many users, how much usage you're going to get, you want to plan for that in your application. And for example, with OnlyBots, we have some throttling capabilities behind the scenes in case this thing goes in one direction or another. We can start to make bots post less frequently, for example, and that allows people to get in. Or we can make it less time before a bot who's not getting a lot of traction starts to go dormant. So you can think about what safeguards to put into it when it starts to get more expensive.
Yes? How long did it take to build? It wasn't that we were building it in sort of a continuous way. So it took a couple months or so, but it wasn't a couple months of work. It was doing it and then coming back and experimenting and playing around with prompts. And so much of it wasn't the logic. It was the prompts themselves and just getting those right. So yeah, but if we had to build it start to finish, what would this 3 months to condense to? So I would say if we really had, because part of it was figuring out what we wanted to work like as we're building it, right? If we had a clear vision of here's what we want it to look like, I think it's 3-4 weeks of building, something like that gets us there. Yeah, rough estimate. Yes. Yeah, it's a good question. So the question is about security, and it is if you're using the embedding model and you get the data back from the vector database, so you have your scope document or whatever document, and you pass it, you still have to pass it to OpenAI using GPT 3.5 or 4 in order to get a response. How do you deal with that? We're transparent about that, and we trust that OpenAI isn't actually storing that stuff. And so that's how we deal with it. There's not some special way to sort of have your own. GPT-4 is proprietary, so we can't use it. If that was an issue, I think what we would do is instead we would use Llama 2 or something like that. We would host it somewhere ourselves, and then we would use the OpenAI embedding API to actually to embed the data, and then we would use Llama 2 to get answers because we would self-host it. I think that's how we would do it. I think, or maybe one last question, then we'll wrap up. Yeah, so the question is embedding the most efficient way to analyze documents, or can you use OCR to extract the text? So I think either way, you have to extract text from a document. So if you have a document, you need to get that document from a document format to a text format. So your document might be in a format where it's very easy to convert that, or it might be in a format where you need to, maybe it's handwritten or something, you need to extract that text. So you would use OCR first to convert from document to text. But then if you have a whole bunch of documents, you need to store them somewhere, and that's what you would use embeddings to then store that text. However you got that text, you would store that and use that. So awesome. Okay, well, thanks so much for being so engaged and for your time. Appreciate it.